So we're going to start with the amount concentration method of conveying concentration. We're going to do that first, give you the most time to practice it. This is the method that you're going to use for chemistry 30. So it's the one you really have to have down really well. We'll do percent and part per million, part per billion later. They're probably a little bit more tricky, and they'll just end with this course. Those are more used on consumer products, the part per million, the percents. You might go to the grocery store and buy vinegar, and it might say 5%. Chemists need to use moles for our calculations, so this is the best method. So concentration is going to be moles of solute. So we might weigh it, but we're going to have to do a mass to moles conversion on the top. And then our denominator isn't the solvent, it's the total amount of solution that we have. And that's going to be our denominator regardless of the type of concentration we do. Now in chemistry, we use a lot of glassware that measures total volume. We use graduated cylinders that you've used before. Well, you can just put in a solute, fill it up to the 150 mil mark. You don't have to worry about how much water you put in. You just fill up to a certain line, and that's total volume. We're also going to use some more expensive glassware in this course that gives us 4 or 5 significant figures on our total volume. So we'll see that later. So often that relationship I started with is shortened to concentration as N over V. Okay. We'll end up rearranging that a bit. When you do solution stoic, this is how you're going to get moles, and when you rearrange that for moles, you get concentration times volume. The accepted standard units to use is going to be moles, obviously will be our N. Our concentration needs to be in moles per liter. Okay. We're not going to use moles per mil, but most of our measuring devices are in milliliters, so that'll be a common conversion. Okay. Volume for our math will be liters. So now we have 3 different ways to get moles depending on what we're working with. If something is pure, that's what you learned back in Science 10. You can get moles from mass of that pure substance divided by molar mass. Okay. If you have a gas, you can use PV equals nRT. So moles is PV over RT. And now we're just getting a third strategy, okay, but they're useful in different circumstances. Now, if you have a solution, we have this C times V, and that's going to be our focus here. Just a reminder on the state, so solutions doesn't mean liquid, solutions mean solute and solvent. Pure substances are our solids, our liquids, and our gases that are not mixtures, that are not solutions. Okay. It doesn't happen a lot. It'll happen a little bit more in Chem 30. You might have a pure liquid. In Chemistry 30, we will burn pure methanol or pure ethanol. It will be a pure liquid, so you can't use the solution formula. We can actually weigh the pure liquid, and we'll do the top pure method. So I'm going to do 2 questions, and then you're going to practice this. Essentially, we're going to have 2 steps most of the time. You're going to be given mass. You're going to have to use that to get moles, and then we just figure out our volume or do a unit conversion. So what is the, so there's that heading coming up again. This is the correct vocabulary to use with this type of concentration. Amount means moles. What is the molar concentration of a 250 mil aqueous solution? So that's the total solution, and there's a little over 25 grams of salt, sodium chloride, added into solution. Okay. So setting this up, concentration is moles over liter volume. We've got to have to do a little bit of work for both the numerator and denominator. I'll start off with the numerator, the moles. I want moles of sodium chloride. Make sure you go from words to the formula. In this case, sodium chloride is sodium in group 1 that has a +1 charge, chloride in group 7 or 17, 7A or 17, that's a -1, so you have one of each. Okay, sometimes you have more than one and you're going to need that to get the molar mass right. So our moles, this is a pure substance, pure solute that was put into solution. 25.2 grams of pure solute, and we need the molar mass. 1 sodium, 1 chloride is 58.44 grams per mole using your data booklet. Grams cancel, and we have 0.428 moles. And that's really the hard part. Again, the most common error that I'm going to see is the molar mass being incorrect because you never wrote out the formula and it was maybe calcium chloride that has 2 chlorides for every calcium and you didn't double the calcium. Bottom, we need liters. I'll stick my units in right away, and we have 250 milliliters. Okay. This is a conversion we're going to do a lot. It's one I hope you just get used to doing in your head. Okay. So we need to go to liters, and if you logically think through, milli to the base is going to be 1,000. Okay. If you multiply by 1,000, you're going to get 250,000 liters, which will just make no sense. Okay. It's a divide by 1,000. Now your Alberta data booklet inside has the meaning of all the prefixes. So if you do forget, you get mega on the bottom of page 3. You have the meanings. So you take 250, divide by 1,000, and we have 0 point. Okay, so that's not a significant digit. We've got 2, 5, 0, 0, and I need to keep those end zeros. These are 4 sig figs. Okay, so that was probably from a graduated cylinder that you could read a decimal place on. So my final concentration is 1.71 moles per liter. Now to give you a little perspective, this would be a pretty high number to see in Chem 20 or 30, doable, but high. Okay. Most of the acids, you can't put much more than 12 moles in a liter. Okay. Eventually it starts precipitating out and separating. In labs, we use 0.1 mole per liter or 1 mole per liter a fair bit, 1 being a fairly high concentration. If you get a number like 100 or 1,000, that's often not possible. So I'd go and double check your work. Maybe you're off by 1,000 and you should have got 1 mole per liter instead of 1,000. There'll be a lot of multiple of 1,000 errors that hopefully you can notice and go back and catch. So this one had that 1-to-1 sodium chloride ratio. Hopefully it'd go fairly well when you do this on a test or quiz. The second one is the one you really need to write out that formula. So what's the amount concentration? Same volume, but we have a little over 2 grams of calcium hydroxide. amount concentration, N over V. I'm going to kind of do it backwards. This milliliter to liter, you're going to do in every question. It's always a divide by 1,000, and we have the same mill so we had in the previous question. So I'm going to do that volume conversion. Hopefully this is something you just do in your head. But we need to get the moles. We have calcium, which is in group 2, so that's a 2+ ion. It's written right in your data table. Hydroxide, that's not a monoatomic ion, it's a polyatomic, so you have to look it up, and that's -1. So that will not balance the calcium by itself. We need 2 hydroxide ions. So there's 1 calcium, 2 O's, and 2 H's in this formula unit. Once we have that, we're good to go. Moles, calcium hydroxide, mass, divide by molar mass. Okay. Solutes tend to be solids, don't have to be. 2.25 grams. Okay. Now again, we look up the mass of 1 calcium, 2 O's, 2 H's. Okay. On quizzes, I love to put a group 2 metal with something that's -1, and there might be a third of the class not double the negative ion. Okay. The correct molar mass is 74.10 grams per mole. 0.0304 moles. So you leave that whole thing in your calculator. You do the volume conversion in your head, the divide by 1,000. And I get 0.121 moles per liter. Now, calcium hydroxide is a solution that you can't make up very concentrated. It's not very soluble in water. So you have a difficulty putting any great amount. You might have a struggle getting this amount of calcium hydroxide into water. You might have to heat it up to get it to dissolve and dissociate.